Hello everyone, welcome back. Today's video is going to focus on generators, which are essentially a shortcut for designing iterators. And they are going to basically function the exact same way as iterators, but the main difference is that you're going to be able to write them a lot quicker. So let's get started. So we have a nice long string of the letters of the alphabet, and let's write a generator that's going to allow us to iterate over this string, printing every other letter. And so what we do is we write DEF. So when you're writing a generator, you look like you are writing a function. So we're going to say def every other, our general iterable object, we could call it L. Okay, and then we say for I in range starting at 0, going up to the length of L minus 1, and also only taking every second item, because our goal is to print every other letter of the alphabet. So we're going to go A, C, E, G. And now here, if this was a function, we would say return L of I. But this is not a function, this is a generator. So we type in the word yield. And now let's create an actual generator. So we're going to say IT is every other of S. And we can look at the type of IT, and we can see that indeed it is going to be a generator. And now we can use our IT, our generator, to get the items of our list every other. And so we do this by typing next of IT, and this is going to give us the first letter. We type it again. This is going to give us the next letter, but recall we are skipping every other. This is going to pop out C, and then next again, and we get a good E. So this is all well and good. What we really want to do is we want to be able to write a for loop using our generator. So for this, we say for letter in every other of S, colon, print letter. And this is going to print every other letter of the alphabet. So this syntax is a bit much, but it really is quite powerful. They were able to get this in, essentially it was 3 lines of code to define this generator. If we wanted to use iterators, let's take a look at how much work we would have had to do. I'm not going to make you do it, so you're done typing for the day. Relax, take a nice deep breath. Okay. So we got where we say we'd have a class called a funny list. This is a list where you print every other item. We're going to do an initializer where we do underscore underscore init, self comma L, self.L equals to L. We should probably come up with a printable class since we're defining a whole new class. And we're going to use return str of self.L. And then we got to create an iterator. And now our funny list iterator, which this is an iterator, skips every other item. Funny list there should be lowercase to match what is up above. And okay, so now we have an initializer, and then we have to implicate this next method. Here we have to be a little bit careful in our stopping criteria because we have to make sure we might never actually hit the last item of the list exactly if there's an even or an odd number of items. So we're going to check if we're greater than or equal to the length of safe L. And then we have to move 2 spaces at a time. So this is way more code. It almost takes up the whole screen. But we can check it works the same way. So to summarize, generators are a shortcut. They let you get the same behavior as iterators, but much faster. So that's where I'm going to stop for today. Have a good one.